We present a system for visualizing multidimensional surgical performance data collected from robotic surgical devices. This dataset captures 300 laparoscopic block transfer training tasks performed by more than 50 surgeons. Specific variables recorded include Cartesian tool position, tool rotation around the shaft axis, tool grasp force, tool grasper angle, and time. In all, more than 4,000 frames of data were collected. If watched in sequence, it would take almost 4 hours to watch all of the video data. A brushing interface is used to query the data. The selection is automatically refined to include important surrounding data frames for context. Then, new data views containing only the relevant frames are displayed. For example, this fast interactive selection pulls out the subset of data frames that correspond to a handoff of the block from one tool to another. Video visualizations are augmented with graphs showing the forces applied by each hand. Without visualizations like these, it is nearly impossible to understand surgeons' use of force by watching a surgery, except in the case when it is too late and excessive force has already damaged tissue. Tool traces are examined in more detail using a 3D visualization technique that encodes 14 variables from the dataset. The color of the tracer curves encodes grasp force, the thickness encodes speed, and so on. The 3D visualization provides understanding of actions that are difficult to perceive from the single viewpoint of the laparoscopic camera, such as the difficulty of aiming in the depth dimension. One new trend in the use of force that we have discovered using this tool is a pattern we call sympathetic grasp release. At the instant when one tool grasps a block, the other tool often shows a release, even when this tool is not involved in the current action. More testing is needed to learn how to best interpret and take advantage of this pattern in the data. However, we are optimistic that this and other new findings can ultimately play an important role in helping to understand emergent surgical datasets and ultimately improve training of these important challenging skills.